Alrighty, let's take a look at Features of Functions 5.2. Now the spring break is over, it's back to work. Unless you're watching this over spring break because you just like to keep up on your math, but probably not likely. Anyway, these first ones are just systems of equations. So we just graph them and see what we get. And what we're looking for is where f of x equals g of x. In other words, where do they intersect? Okay, now if we look at these equations, that f of x and g of x can throw some of us off. But remember, that's just like the slope-intercept form. Alrighty, well, I had some students come in, and now I forgot what I was saying. So, let's just start over again. We are graphing these systems, and they're in slope-intercept form even though they don't look it. They're just using the function notation instead of the y. But it's the same idea. It's that mx plus b. So, let's get our x and y axis here. Okay. So, we've got to start out with -7. Draw our starting point. Then our slope is 2, so we make it a fraction, 2 over 1, up 2 to the right 1, and we can follow that pattern. This kind of graphing, you guys should be pretty pro-ish at it. And I might have just made up a new word. So then we just connect the dots and draw our line. So now we need to graph the second one. So this one we start at a positive 5. 1, 2, 3, 4, 5. Starting point right there. Then it's -4 for our slope, so -4 over 1, we go down 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And we're looking for the place where they're equal, so where they intersect. That's what the f of x equals g of x. Where do they equal each other? Right there at that point, which is 2, -3. So that's where they're the same. Alrighty, let's try the second one now. Same idea. Start at -2. Our slope is -5 over 1, so we go down 5 over 1. Or, since we ran out of space, we can go up and to the left. And over 1. Get our graph. Then we graph our second one. We start out at a positive 1. We're going down 2 and to the right 1, down 2 to the right, down 2 to the right. Or we can go backwards and go up 2 and to the left. And you should see where they're going to intersect. Right about here, which would be -1, +3. So that's where they're the same. That point is where they both are the same. Okay, so that's really all you got to do. You just find that y-intercept because it's in the slope-intercept form. So +4, let's draw our axes here. So up 4. Then our slope is 2/3, so we go up 2 to the right 3. Because the top number tells us how far up or down, the bottom number how far to the right. And we just follow that same pattern. And we can even take it backwards. It's that same pattern. If you remember when we were talking about arithmetic sequences, it's that same pattern, adding the same thing over and over. There's our line. Then we do it for the other one, start at +1. This one's got a slope of -1/3. So instead of going up, we go down 1. And to the right 3. Or we can go up 1 and to the left 3. Should be able to see exactly where we are crossing and find that answer. Where are they the same? Where does f of x equal g of x? Well, that point right there, which is -3, +2. Alright, now the other ones deal more with what we've been talking about, and those features. okay, that help us describe a function. So decreasing, increasing, the minimum, maximum, domain, and range. X and Y intercepts are another one. And anything else you can think of that can help you talk about it. So, if we're looking at this first one, it's kind of disjointed, isn't it? It has some discrete aspects to it and some continuous aspects. So, if we're thinking about the decreasing, well, where is it decreasing? Remember, we always look left to right. So it's going down here and here. Okay, so we could say it's decreasing from, remember, we use our x values kind of like on a football field to judge where they're going. So we've got from negative 13 to negative 10, and from negative 2 to positive 5. We've got it decreasing. So we could write that using those cool little brackets. Negative 13 to negative 10, and negative 2 to 5. Okay, so where would it be increasing? Well, we've got those three areas, right? 7 to 12, negative 10 to negative 6, negative 7, and then negative 6 to negative 2. So we could write all of those. Negative 10 to negative 7, and then from negative 6 to negative 2, and then from 7 to 12. Okay, so there's one aspect of it. Okay, now that domain, remember that a domain is the possible x values, and the range are the possible y's. So let's delete the increasing and decreasing. Okay, so our x's start here at negative 13, and they go to negative 7. Then negative 6 to 5, and 7 to 12. So the domain is all those numbers from negative 13 to negative 7, negative 6 to 5, and 7 to 12. Now the range, remember the range is the y values. So we start down here at positive 1, go up to 4, and this one have that overlapping area of the range. That's alright. Then we go from 5 up to 8. So for the range, we're talking about 1 to 4 and 5 to 8. Okay, so there's just a few ways of talking about it. X-intercepts. There aren't any x-intercepts, so we wouldn't list that. Y-intercepts. We've got the 1 right here at positive 3, so y at 0, positive 3. Okay, minimums and maximums. What's the highest we go? The highest would be that point at 6, right? So the minimum at the point negative 7, positive 8. Not 6, 8. Oh, that's max. Sorry. Making mistakes here. The minimum's how low. So, and we see that it has two of them, right? At negative 6 and 1, and at positive 5 and 1. Okay, so then if there's any other ways you can talk about describing it, you can list them. But those are the main ones we're looking for. Okay, now number 8, this one's quite a bit different, isn't it? So if we're looking at 8, this is an exponential function. Remember, it looks like it straightens out, but it's actually going to keep going down extremely slowly. Extremely slowly. So, as we look left to right, is this ever increasing? Nope, it's just decreasing. And where is it decreasing from? Well, if we keep going up, we're going to keep going to the left. When we keep going to the left, we call that negative infinity. When we keep going to the right, we call that positive infinity. So if we're talking about when it's negative and when it's decreasing, it starts out at negative and just keeps going to positive. That's how you write it. Because it keeps going left and right, our domain is also going to be that. Pretty much any x number I choose, we're going to be able to find it on the graph somewhere. Now, we don't have any time that it's increasing, so not happening. So we don't even need to write it. We can't see a y-intercept or an x-intercept, so you could test to see where the y-intercept is if you had the equation, but since we don't, we can't really go with that. A minimum and a maximum, it's just going to keep getting bigger, so we don't really have a maximum. And the minimum, it looks like it's getting to this place right here. If you recall when we talked about exponentials, they have this point that they never go below or they never go above. And it's called an asymptote. And so there, where y is 3, that's where we're going to have an asymptote. So we don't really have a minimum because our graph keeps getting closer and closer to that, but that is a point to think about when we're dealing with our range. Because our range is going to start at that 3 and keep going up. So for our range, it goes from 3 to infinity. It just keeps on going. So on some of these, you may not be able to say all the pieces, but you can still describe it using some of them. Alright, now the last ones are just kind of reviewing the explicit and the recursive. So just a reminder, especially for those that still are struggling with this, the recursive formula just connects the output values, the f of n, or the y values. It's a connection from how I get from 5 to 2, from 2 to 1, negative 1. And there's a few ways we can write it. You can write it f of n equals f of n minus 1, okay, where it's the next term is equal to the previous term. Or we could even write it like this, a sub n equals a sub n minus 1. And honestly, we could even write it f of n plus 1 equals f of n. There's multiple ways of writing it, but it still means the same thing. Okay? Still means the same thing. So, how do we get from 5 to 2? From 2 to negative 1? Well, we're subtracting 3 each time. So we take that previous number and we subtract 3 from it. And then we have to say, well, where are we starting? What's our f of 0? We could write f of 1 equals 5, but it's a pretty good habit to get into is to always find where that 0 would be. So we'd have to go up to 8. So f of 0 equals 8. That's our recursive. Now with our explicit, that's the one where it connects this side, the input with the output. So that's the connection they're looking for on that one. So we start out the same, saying f of n equals, then we say, well, where did we start? We started where n was 0 and it equaled 8. So we write that. Then, what did we do to each of these as we were going down that output side? Well, we're subtracting 3. So we subtract 3 from 8. And if we keep going each step, we're subtracting 3 again. So what does that mean? Well, it means that as we keep going down, we're getting to some point when we don't know how far. But each time for each n, we're subtracting a 3 again. So it's that repeated subtraction, which the shortcut, the quick way, is through multiplication. But since we don't know how far we're going, we just take that negative 3 and we times it by our variable. So our explicit is the starting point, then that slope, that growth, and we times it by the variable. So you should be able to recognize that this is a linear or arithmetic pattern going on here. Okay, let's take a look at number 11. Now we're going from 6 to 12 and 12 to 24. So we can't just add a number to get this to work because we'd be adding by a different number. However, we can think about multiplication. 6 times 2 would give us 12. 12 times 2 would give us 24. And we probably want to work backwards to get when our n is 0. So we'd go backward and say it's 3 because 3 times 2 equals 6. So we can do our recursive. We can say our next term is equal to our previous term. And what did we do to it? We multiplied it by 2. And where did we start? Our f of 0, or in this case, a sub 0, equals 3. And then for our explicit, it's the same idea. We start out, and our starting number was 3. What did we do to it? We times it by 2. Now because we're doing that repeated multiplication, the shortcut to repeated multiplication are powers. So since we don't know how far we're going down, we put our variable up as an exponent of that 2. Okay, now just to remind you, the recursive and explicit are related. Okay, this times 2, the times 2, the 3, the 3. Okay, even with our number 10, same idea, the minus 3, the 8. Okay, you can use the 1 to find the other, but that's the basic idea. Now, if we take a look at number 14, this one looks a lot more difficult. Okay, but the first thing you have to notice here is right here on this, the input side. Those aren't following a pattern. Okay, so what you can do is try to fill in the gap to this to help us out. Okay, so 2 we had 5, 7 we had 15,625, and at 9 we had 390,625. So if we're trying to figure out how we get from one to the other, there's a few different methods we can use. Okay, and the way we've got to think about it is, as I go up each one of these numbers, I'm either adding or multiplying by that same number each time. So when we do it, let's see, 1, 2, 3, 4, 5 times. Okay, so we're going to have to multiply or add by 5 times. So it can be hard to tell to begin with. So if we're adding, what we need to do is we need to go 15,625 and subtract the 5. Okay, that would give us 15,620. Then we divide that by 5 to figure out what number would be added. So you grab your calculator, type that in, divide by 5, and we get 3124. That would be the number we'd be adding by. So let's test it. 5 plus 3124 equals 3129 plus 3124 equals 6253. Do it again. We get 9377. One more time. Now, if we don't end up with our answer, then it means that something's not working. We got something wrong. So let's do it another time. See if we come up with ours. And we don't. We come up with 25002. So it's not addition. So all that work we did was merely to eliminate one possibility. So if it's not that, let's try to see if it's an exponential, if it's multiplication. So to do this one, you take the 15,625 and divide it by that other number. Okay? Because if we're talking about multiplication, we're kind of doing the opposite. So we divide it by 5, and we get 3125. Then, because we have 5 steps, we're going to take the 5th root. What that means is, what number timesing itself 5 times would equal that? That's what the root is essentially telling you there. So let's use our calculator, and you can find a calculator online that could do the 5th root for you if you can't do it on your phone or a calculator you have. And that gives us 5. So what that means is if I go 5 times 5 times 5 times 5 times 5, that's going to give me this number. So that tells me that I'm multiplying by 5 each time. So let's check it out to see if it works. 5 times 5 is 25, times 5 is 125. 125 times 5 is 625. Times that by 5 again, we get 3125. Times it by 5 again, we get 15,625. Times that by 5, we get 78125. Times that by 5, and we get our last one. Okay? So that's one way you can try to figure that out. Okay? And then once we've got that information, we just work backwards to 1 and 0. So 5 divided by 5 would give us 1. 1 divided by 5 would give us 1/5. So for our recursive, we say to get our next number, we take that previous number and we multiply it by 5. And where did we start? Well, we started at 1/5. Okay, there's our recursive. Notice this one I put n plus 1 because we're going up to the next one, and we take the previous one just as f of n. Now, for the explicit, we say f of n is equal to, well, we start at 1/5, and what do? We times it by 5. How many times? We don't know. That's our variable, so we put it as an exponent since we're multiplying. And there we go. There's the main gist of this homework, and hopefully you guys can do better on the other ones that we didn't do.